We're continuing here on in chapter 5. Today we're going to talk about corresponding parts of congruent triangles are congruent. So the first question I have is I look at these two triangles and I ask you, is angle B congruent to angle M? And our brain is telling us yes, but it's not marked in any way. But what I do know is I know that triangle BAC is congruent to triangle MLN. And I know that because it is a side angle side relationship. So it stands to figure that B and M should be congruent. We'll come back to that. Let's take a look at this one. Is AD, side AD, congruent to side BC? And the answer again, it looks like it should, but it's not marked in that way. But I do know that AC and CA are congruent. And that is by the symmetric property, which then would give me that triangle ABC is congruent to triangle CDA. And we know that because of angle-angle side relationship. So it stands to figure that AD and BC would be congruent, but we don't know that for sure yet until we think about what we're learning today. Remember that congruent triangles have 6 parts that are congruent. 3 pairs of corresponding incongruent sides and 3 pairs of corresponding incongruent angles. And this property that helps us with this is called corresponding parts of congruent triangles are congruent. In other words, what we refer to as CPCTC. CPCTC. Now, in order to be able to say that corresponding parts are congruent, you have to tell me that you have congruent triangles. So, before using CPCTC, you must prove triangles are going to be congruent. Okay? So when we look back at this then, let's jump back to that first slide. What could we prove then? Well, since we know the triangles are congruent, we automatically know angle B would be congruent to angle M by CPCTC because we know the triangles are congruent. We also would know angle C is congruent to angle N. Why? Because of CPCTC. Congruent parts of congruent triangles are congruent. We also would even know BC, side BC, would be congruent to side MN, again, by CPCTC. So once we prove triangles congruent, we know all the additional pieces that we don't already have would also have to be congruent. Okay, so let's take a look at a proof with this then. What does this look like? Well, let's go through and mark up some things that we know. So what I'm going to use is I'm going to use red for things that are given. So here I know that G and N are congruent. I know that. It's given to me. I also know that HK bisects this angle right here. Okay? So since it bisects that, then what I know I can prove, I know I should be able to get to the point where I can prove those two are congruent. Now, if you think about the 4 ways that we use to prove triangle congruence, we know side, side, side. Well, probably not using that because I have 2 angles. I know side, angle, side. Probably not using that because I have 2 angles. The 2 that I'm looking for is either angle, side, angle, or angle, angle, side. Remember, in order to be angle, side, angle, you would have to be able to get this side congruent to this side because those are the overlapping or the ones in between the 2 angles. Or we could do angle, angle, side, which is any of the exteriors. Now, when we look at this, the easiest one to get would be HK because HK is congruent to itself. So I believe we're going to use triangle congruence by angle side. So here we go. Let's start then. I already have the G to the N, so now we start to the next part. Let's just do the angles. So angle GHK is congruent to angle NHK. And that is because definition of angle bisector. I also know that HK would be congruent to HK, and that is the reflexive property. Well, now if you look back, you have an angle, and the side outside of that. So we know that triangle GHK is going to be congruent to triangle NHK by angle side. Then that gets me to my proof statement now. So now I know those two triangles are congruent. So I know GK is congruent to NK. And that is by CPCTC. Now, I just want to show you again, remember, I have triangle congruence, and then that leads me to CPCTC. Okay? So the triangle congruence there leads me to the statement that uses the CPCTC. All right, let's try another one. So what do we know? Well, it tells me that angle B is congruent to angle D. It also tells me AC bisects BD. So what that means is I should be able to prove those two sides are congruent. Lastly, I've got to figure out, okay, which one am I using? Side, side, side? No, because I have an angle and a side. Side, angle, side? Could be. Angle, side, angle? Could be. Or angle, angle, side. So if you notice on those, we want to look, is there a way to get another angle or another side? And there is. I have this middle angle right here, and that is from vertical angles. So when we look at this then, we're just going to start with the side. So we're going to go BE is congruent to DE. Why? And that is the definition of a segment bisector. Okay. I also know angle BEA is congruent to angle DEC. And that is the vertical angle theorem that says two vertical angles are congruent. So now you look back, you have an angle, a side between them, and an angle. So now we know triangle BEA is going to be congruent to triangle DEC by angle side angle. So then that gets me my proof statement now, which is angle A is congruent to angle C by CPCTC. Congruent parts of congruent triangles are congruent. All right, let's try this last one then. Let's take a look at it. So what do we know? Well, we know that F is congruent to M. We know that. We also know that FL is parallel to PM. Okay? So remember, with the parallels, we get an opportunity to get some angles. So what's the easiest we're going to go with is angle 1 to angle 2, because those are alternate interior angles, and the sides that they open to, this side here gives me angle 1, this side here gets me angle 2. If the opposite sides were parallel, then you would be able to use 4 and 3. So it depends on which sides they give you. Then the last thing I'm going to need is a side, and I'm going to just go with the one in the middle. Be careful there, because as you notice, those triangles are rotated around. So that's also going to give me a different length for those middle pieces. So I'm going to start with the next part. I'm going to say angle 1 is congruent to angle 2, and that is by the alternate interior angle theorem. Then I know that side PL is congruent to side LP. That is by our symmetric property. Now, if you look, you got an angle, and a side, and it's not the included. So now I have triangle FLP congruent to triangle MPL. And that is by angle, side, because the side is not included. So now we can go to our proof statement. FP is congruent to ML, and that is by CPCTC. And that is how we use that congruence. Parts of congruent triangles are congruent.